And we might keep recording it anyway. So this morning I got the link for the test that's going to be in WebAssign. So I looked over it. So I'm going to give you kind of a breakdown. Basically, there's 13 questions, and they scan pretty much the full range. There's one question out of almost every topic. One has 2 topics. They're going to be having it run with a lockdown browser, so you'll want to have lockdown browser installed previously on your computer. I'll send out a link. WebAssign has a link that you can download it. If you already have, like I already had lockdown browser installed previously and it's got all the updates, you'll be just fine. There'll be a page where you can test your lockdown browser. But what you'll have to do is join, like you're doing now, join the Zoom meeting first, and then open up your WebAssign. So I'll have some instructions about that, but I tested it. The lockdown browser allowed the Zoom meeting to continue running when I tested it this morning. So come to the Zoom meeting, then you can open up your lockdown browser with the test, and I've got it timed so the test will be available exactly at 10:30. It's a little earlier, so if you want to, and I'll open class a little earlier, and then we've got 15 minutes to take the test. It's 13 questions, and it is after I finished up all the reviews, making videos for all the review questions that were posted. And those questions will definitely address the types of questions. Some are very, very similar. Others, the questions themselves are different, but the concepts that they're doing is the same. But basically working through that test 2 review, the study guide, you will be right on spot for all of them and be well prepared. Okay, and let's see. So basically that's all we have. There are no more homework assignments. I think I did extend 12, 5, and 6 both until through the weekend, but you'll want to get all the homeworks completed fairly soon, and so that you can focus on the study guide in Canvas. Okay.
Is there a quiz on Friday?
Questions?
Is there a quiz on Friday?
Yeah, we'll do a quiz. It'll be as a run through. I'm thinking you could, as long as you have access. The reason for that, it'll be a 1 question. It's not really. I'm not doing it sort of as a way to just get ding people for not being here or anything, but it's more. It's for a run through. So I want you to just practice opening up Zoom, then opening up a 1 question quiz, because if that all works, the test will work. If it doesn't work, then we can get your system, we can work through the bugs. And then I'll also have a link in Canvas where you can upload a PDF file. So I want you to, basically that's all just a test, a run through to get ready for the test. So yeah, on Friday, we'll do it during our Zoom meeting. So I really highly recommend everybody come in during the Zoom meeting to give that a try as a first run through. But again, I know a lot's going on right now, and I'm not in the mood for doing anything sort of, what do they say, to punish or penalize people for things that they can't control. And I know I'm talking with one of my 117 students, and many of you are in different time zones now, but let's do our best to make it work. And as long as you're able to come in on Wednesday and make the test work, that's great. But I want to use Friday, and we could also always follow up on Monday. But I want to make sure that you're up and running for when the test comes. Reduce stress and all those kind of things.
Now, as far as webcams go, I don't have a webcam, so how would I proceed to do that, especially because I can't really, buy one?
Yeah, I know. I've tried to, even I needed a hard drive and I went on Amazon. They told me they could get me one next month. And I said, oh, that's great. Fortunately, I found one locally, but I understand. Do you have a cell phone or a tablet?
Yeah, I have a cell phone.
Okay, so the Zoom has a cell phone app, and that's really all we need is if you can get in the Zoom meeting, that will at least give me so I can see your face, so I can see you are the one taking the test. It's so it doesn't have to be on your computer, but that's really all we're using Zoom for is that. In fact, I don't know if you guys see it, but what I see in gallery mode is I can see up to 25 students, either icons or pictures here, and then once you turn on your webcam or your phone, it would show your face, and that's all I'm going to do is I'll be there to kind of to proctor. So if you that will be a
Is it
back.
closed note?
What's that?
Is it closed note?
Right, it's just like all the others. There's no
okay.
notes. You get a piece of scratch paper, and that's you'll hold up that's all you have. And I'm kind of going on it's a different setup. We're not in class. It's some of the instructors are worried about security. That's why we're doing the Zoom meeting with video. That'll be the proctoring. The lockdown browser will lock down your computer so you're not accessing internet sites. Usually we don't say, you can't use your cell phone, but in this case, using your cell phone allows you to be on the Zoom meeting. And I believe you'll all, because the tests, if you do the studying in advanced, going through that study guide, if you go through, I know it's about 4 hours of videos that I made, maybe it's closer to 5. I sort of lost track. But if you go through all of those are the types of questions that are on this test, and they come from WebAssign, so they're very, they're like the homework ones, but they're not the really out there homework ones. They're pretty straightforward. So does that help? So again, I would use your cell phone, download the Zoom app, see if you can join that way. But we'll compensate. We won't make, we're not here to make your life more difficult. It's already hard enough. And I know that, you can't get things now. Most of our electronic stuff is made in China, and there's back orders on everything. And it's just, it's really rough.
Question.
Yes.
So for the test, it's a lockdown browser, but it's not a webcam browser.
No.
We're relying on our Zooms on our phones to be in webcam mode for you.
Right. Yes, you got it.
Okay.
Yeah.
So the camera, my computer camera will not activate. I have to zoom in a separate device.
Yes, that would be great. That'd be great.
Okay, I got you.
Yeah. And again, it's not perfect, but it's what we have. We're going to make it through. And again, I believe in you guys being, as honest and straightforward as you can be. And, the other thing you're going to want to do is, and again, I'll put some instructions in, is have something. I use Cam Scanner on my phone. It can take a picture of a page and turns it to a PDF, and it can do multiple pages. Then you save it as a PDF and you can upload it to me. That will allow me to give partial credit for any incorrect answers. So it'll be like a WebAssign. It'll grade it. You won't see that because it's a test, but at the end it'll manually, or on the computer it'll grade it. I'll go through, and anything that you miss, I can then look at your work and give partial credit or even some more. If I can see like, oh, you just missed a negative sign, or worse yet, you had the answer correct on the paper, but the test what got entered was different. So that's where the scratch work will be helpful. Again, if you've got a correct answer, you'll get it. We're not gonna go back and say, oh no, there wasn't enough work. That's the instructions I got from the coordinator. So, but we do want the work submitted so that anything that didn't get full credit, I can give some partial credit on or more, again, and if it was like a rounding error, was off by the 3rd decimal place, I'm not going to get that picky unless it's so.
Is now a bad time to ask a quick homework question?
No, it's actually good. Otherwise, I'll just start talking about nothing important. So thanks, John. What do you got?
Yeah, so I just didn't understand this problem. It was 5 natural log t minus 5 minus 1 over t. And I was confused on how they got the final answer, which was 5 over t plus 1 over t squared.
Okay, let me back that. Let me get set up here. What do I want to do? Let's go here. Okay. Let me share the screen. I'm still recording, so that's good. Okay, you can see my screen now. John, could you go ahead and read that question, the problem again to me so I can write it down as we're going?
Yeah, it was 5 natural log t minus 5 minus 1 over t.
So that's what they started with?
Yeah.
That's the function? Maybe like
Wait,
that.
is this 12.5 or 6?
I think it's 12.5.
All right.
Okay, and then what did they ask? What was the question asking? I apologize.
I couldn't tell you. I just have it written down on my notes. But the final answer was 5 over t plus 1 over t squared, and I was just confused on how they got to that.
5 over t
Plus 1 over t squared.
plus 1 over, okay, good. Okay, so they're just wanting the derivative, okay? Like from that answer. So when we take the derivative of t, the way they got that is this part, so it's term by term.
Yeah.
This part, its derivative, whenever you take the natural log of t, its derivative is going to be 1 over t.
Yeah.
Okay, and so the 5 is a constant multiplier, so what we end up with is 5 times 1 over t, which becomes just 5 over t. So that's how they got that part.
All right.
Derivative of -5 is 0, so it disappears, it's gone.
Mm-hmm.
And then the derivative of 1 over t, what you want to do is you want to think of this as t to the -1. So when you take this derivative, the -1 comes down, so that's why this negative became a plus.
Mm-hmm.
And then you subtract 1 from the exponent, so that becomes t to the -2, which moves it back down to the denominator. So they just rewrote this as 1 over t squared. So that's how they got that part.
Cool.
Okay, good. And there's with that in mind, there is a question on the test that deals with this sort of question here, same type of deal of taking the derivative of a natural log. So that is something important to know, that the natural log, when you take its derivative, it's just 1 over t.
All right.
Did you also do number 6 on 12.6?
12.6, you got it. So let me, starting my notes here, log in. .6 and number 6, right?
Yes.
Okay. Wow.
Yeah, that was tough.
It's like pretty much the same as number 7.
Okay, good, good. So it's nice we can answer one and it'll
I think so.
Get us close to it. So what I'll do again, let me do a screen print of this. And so it'll stay in the notes that way.
Does that say Q minus P plus B or Q equals MP plus B? Right.
Q equals MP plus B. So it's just saying it's a linear equation. And again, this, just to let you know, since you guys are here, this will be helpful for the test as well. So now that I've got this, let me get into Word. We'll just.
And how many questions on the exam will be multiple choice, and how many will be just written out answers?
They are actually all, because of this is a web assigned, they are all fill in the blank.
Okay.
So they're just like doing the homework. That's really what they've done, is they've chosen, because it's still from the same test bank. So you have to actually type in the answers.
And can you submit answer once you figure that one out, and it'll like tell you if it's right or wrong, or do you have to wait till the end?
Unfortunately, the way the tests work is you get all the way through the test and you submit at the end.
Gotcha. Okay.
And then that's when I get to review. Let's see.
So you don't get 5 tries on the exam?
No, unfortunately.
All right. Cool.
Let's see if I can. Let's just start with something new. Okay. Let's put that question there. Okay, so you have been hired as a marketing consultant, blah, blah, blah. So we're assuming that the equation is a linear equation. So I'll write that a little bit bigger. Q equals the slope times P plus B. And so P is our X, Q is our Y. Is the demand in weekly sales. Okay, so your market studies reveal the following sales figure. When the price is set at $2, so that's when P equals $2 or 2 per hamburger, the sales amount to 5,000. So Q then is equal to 5,000 per week. But when the price is set at $4, when P is 4, the sales drop to 0. Wow. Nobody wants $4 hamburgers. So what they've given us is they've given us 2 points. 2, 5,000, and 4, 0. So we can come up with this linear equation. So the first part is to find the slope using the formula y2 minus y1 over x2 minus x1. So that's going to give us 5,000 minus 0 over 2,000 minus 4. So notice that'll give 5,000 over negative 2, which is negative 2,500. Okay. Notice that when 4, we get 0, which y is 0. This is our no, the y-intercepts when x is equal to 0. Okay, so we get the formula Q equals negative 2,500 P plus B. To figure out what B is, we plug in one of these 2 points. Let's go ahead and use the 2 and the 5,000. So when P is 2, see, did I do that right? Let's see. Yeah. Okay, so I'm going to take this point, let's change color. So I'm going to plug the 5,000 in for Q. Put that here. Q is 5,000 minus 2,500. Plug in 2 for P. So we get 5,000. This is negative 5,000 add 5,000 to both sides. You get that V, or your y-intercept, is equal to 10,000. So our equation is Q equals minus 2,500 P plus 10,000.
That's the answer for A.
Yeah.
Okay.
So that's up here. So yeah, minus 2,500 P plus 10,000. So that means that if you were to charge $0 for them, you would sell 10,000. I think you'd sell a lot more, but anyway, that's what this function says. And then basically, for each dollar you increase the price, you'll sell 2,500 less. Okay, so that's kind of what this one is saying. So now estimate the unit price that maximizes weekly revenue. Okay, so what we do.
Wait, I have a question really quick.
Yes.
How did you get that 2,500 in the part that you're circling right now? It's just hard because like I have different numbers, but
Right. Okay, so you find the slope. So what you realize is what they're giving you in the A part, they're giving you 2 points. The price is the X coordinate. The amount sold is the Y coordinate. Okay, so at $2 we sell 5,000. At $4 we sold 0. So those are the X and Y values. And then we use the slope formula. Again, that's what this one is here, to find it. So we put the Y values in. So 5,000 minus 0 in the top, 2 minus 4,000, or 2 minus 4. So we've got this set up here. And again, your numbers will be different, but that gives you, your points are different, but you would do the same process to get that slope.
okay.
Once you have the slope, you put that back into the formula, right? Q equals mx. This is really coming from y equals mx plus b. That's the way we're used to seeing it. They just using different variables. So we plug the slope back in, plug in one of the points. Again, I could have gone with 4 and 0. That would have worked as well. And then what we're doing is we're solving for the y-intercept. So that's how we got this part here. Gives us our function. Okay, so are we all okay with that part?
Yeah.
So now we're wanting to estimate the unit price that maximizes weekly revenue. Okay, this was from and this was from 12.6, right? And 12.6 is the elasticity of demand. And what we found is that when we go to calculate elasticity of demand, that the elasticity of demand is equal to, I'll use this Q, it's minus the derivative of Q times P over Q. Okay. I've also been writing this as in function notation, f of P, which is Q, minus f of P, right, times P. Okay, so either of these, so we're going to do this, so we need the derivative of Q. So let's go ahead and just calculate that here. Derivative of Q of this function, take the derivative here of P, the 1 comes down, 1 times negative 2,500 is 2,500. Derivative of P itself is 1, right? This becomes 1 minus 1, P to the 0 power. Derivative of 10,000 is 0. Okay, so this is our derivative.
Wait, I can't see it.
Was that?
I can't see it.
You can't
Are you
see
writing
it.
stuff down?
Yeah. Let's see. Can you guys see the screen? Is it?
Yeah, I can
Wait,
see
where on the screen are you writing right now?
It should be, I should be sharing the full screen.
top left.
All right, top left. Okay.
Do you see the whole, I'm working in Microsoft Word.
Yeah.
Okay.
All right.
Let me see, I can, let's make it bigger that way. How's that? Let's see, I want a blank page underneath. Sorry, guys. Okay, so what we're going to do is we'll calculate this function here. Apologize. So we have $1,000, and the derivative of Q is minus 2,500. Okay. Minus the derivative of Q times P over Q. So the derivative of Q is minus 2,500. Again, there's a minus, right? The minus is on the Q from the outside. This is 25. We multiply by P over the Q, which is this equation we came up with. So we can, so this negative and negative make a positive. So it's 2,500 P over minus 2,500 P plus 10,000. We will maximize this when E is equal to 1. And remember, think of this as 1 over 1, and we've got a fraction equal to a fraction, so we can cross multiply. So on one side, you get 2,500 P. On the other side of the equal sign, you get minus 2,500 P plus 10,000. Solving for P, add 2,500 P to both sides.
Mr. Little Crow,
Yes.
after we're done with this problem, can I do a quick animal noise in the class to guess which animal I am intimidating?
No.
I heard yes. I heard
No.
yes.
No, sir. This is, Jacob, this is for class time, so
Okay.
please be respectful of that.
Sorry.
That's okay. Okay. And so we've got this. We divide both sides by 5,000. And it appears that the best price is $2. 10,000 divided by 5,000 is going to be 2. So that means that the, go back to the window, the original question. Estimate the unit price that maximizes weekly revenue. That's going to be $2. Okay. Predict the weekly revenue. Predict what the weekly revenue will be at that price. So revenue is equal to price times quantity. You could use so we know the quantity right now at $2 is 5,000. So this is, but if they didn't give that to you, if you didn't get the price, what you would do is you say that this is P times your equation for Q, which remember was minus 2,500 P plus 10,000. Okay, we plug in 2 for each of these. Minus 2,500 times 2 is minus 5,000 plus 10,000. So you get 2 times 5,000, which kind of we knew. So $2 times 5,000 burgers, or what's that, what we're selling? Burgers? I even forgot what we're selling. So our revenue is going to be $10,000.
Okay. And going back to find the maximizing weekly revenue, when you move the 2,500 P to the other side of the equation,
yes,
that was because of the 1/1.
Yes, I did a cross multiply because yes, we always end up with a fraction. Let me see if I got that. Yeah,
I get it.
Yeah,
Gotcha.
and so we also explored doing these types of problems with, you could graph it, you could graph y equals 1 and then y equals the other equation and find where they intersect. But I think all of these problems really, because we're always looking, E is going to be 1 is the place we maximize. That allows you to do this cross multiplying. And because of the way it's set up, you always have a fraction. So it's really just move the numerator and denominators to opposite sides and then solve for the variable. It's is the mathematics that's going on there.
Gotcha.
Good question. And again, there's one very similar to this. It's I don't think it's quite as wordy in the questioning, but it's got the same type of process where they might even give you the linear equation, and then but you still have to go through and find the amount that maximizes revenue. So just I can't stress enough. One thing I do want to bring up here is there's 2 questions that deal with finding the inflection point given a graph, and we didn't do a lot of that, but remember the inflection point came up in when we were dealing with the second derivative, which I can't remember exactly what, I think it was maybe like 11.5 or maybe it was 11.6, but the second derivative one, the inflection point, if you take the second derivative, inflection point, the second derivative is 0. But what they're doing is they're having you find it from the graph, and remember it's kind of the place where it changes from concave up to concave down or the other way around. But it's where you get that S curve. You'll just have to, and on the graphs they give you, it's pretty obvious. There's a pointer there right where that happens. When you have an increasing function that's concave up followed by concave down, you get an S curve. The place that you get the greatest rate of change is going to be at that inflection point. And you can kind of look at it. And the reason I mention this is because we didn't make that we didn't highlight that in any of the problems we worked because we didn't need to. But if you follow that, the tangent lines, that inflection point becomes a place where it's going up, 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 and then at that inflection point, it starts going back down. So that inflection point also ends up being the place of the greatest, the most rapid change. So after that inflection point change slows down, it's still increasing, but it's increasing at a slower rate. So the importance in a business situation of the inflection point, if you find that, that's where you get sort of the biggest bang for your buck. You're changing at the greatest amount. It's also when you need to be most active because, again, that's where the change is the greatest. And then after that, change will slow down. So if you have the data where you can find an inflection point, that's going to be, the inflection point is your place of greatest change. So just remember that. Okay, what else? Any other questions? And
I had a question about this one that we just solved.
okay,
For the revenue problem, did you multiply the Q by just Q itself or Q prime?
by Q itself, I took P times Q.
Okay, so the regular like like 2,500 P plus 10,000 one?
Yes, let me see where, yeah, so P times Q, so negative 2,500 P plus, so this is, yeah, the function that we had arrived at, not Q prime, not Q prime. Just
Okay,
P
sorry,
prime.
I just didn't see it to write that down. I'm just gonna write that down really quick.
Very good, very good. Yeah, again, that's an important, so some of these, we're going back and forth between, you know, the derivative and then the function before the derivative, so. And after test 2, we start doing integration, and so you'll see this connection between the derivative and the function before the derivative even more.
How far are we going to go with integrals? Are we going to go into like areas of the cone and stuff like that, or
No. Those that goes into your because see, this is when they say brief calculus. What they mean is it's a lot of calculus, but we only cover it briefly. We don't go very deep into it. So in the engineering calculus, they spend a whole semester on integration. So yes, they go into cones and generation and stuff. What we look at, because we're doing basically 2 semesters of calculus content in 1 semester, so we just don't go as deep. We're going to look at the business applications, and when we get to integration, the most business application is accumulation. And we're sticking primarily with stuff like profits and revenues and costs, business type applications.
Okay, gotcha.
Good question. And I hope, if, again, as you watch the videos, any good feedback you got from me? I was getting pretty loopy at the end, and I just decided to keep pushing through. I was making a few mistakes, so you'll see them, but I did catch them. At least I think I caught them all. If I didn't, let me know, but I was able to match the answers, so.
What's the formula for
what?
part 2? Like when it says estimate the weekly revenue.
Oh,
Like
okay.
the unit
So,
price.
yeah, so this part, again, mostly knowing from here, it's we're looking for elasticity. So we're looking for unit elasticity, really, because that's where it maximizes. Is, again, you could do it in multiple ways, but it's the derivative of Q times P, which is just the variable, over Q. And again, Q was the equation we came up with. Okay, and then that's why we find, usually we're either given Q or we have to find it in some ways. And when we have to find it, it's usually just, it's a linear equation. And then we have to find its derivative as well, which was just minus 2,500. So that's good. So that's a good, the B part used this version, the elasticity function, and the last part, the B part of the B part, just use that revenue as price times quantity, P times Q. Obviously, no derivative involved in the last part.
What question on the test will most likely need the most work to be shown? What section?
This actually, I'll tell you, it's this one right here. This one, because on the test it has the multiple parts. So it'll probably be this one.
Okay.
Again, I'll back up the direction from the coordinators, which I agree completely with. And I don't want to, you don't have to show any work, because if you have a correct answer, you will get full points, whether you show work or not. We'll put it that way. Where showing the work will be helpful is if you don't get a credit for an answer. And sometimes it might be because of a rounding error or something. So that's definitely where you would want to show enough work to show that you arrived at the right answer. But with that being said, if the WebAssign goes through and grades it and you got 100% on your exam, I'm not even going to look at your work. Okay, I'm not going to look at your work because you got 100%. There's nothing that's going to change. If you got 95%, I'm going to pull up and I'm going to see which one you missed, and then I'll look at your work. And again, yeah, and that's. I'm hoping you all get 100%. It makes my weekend really nice.
All right.
Okay, because it is going to be a little. I'll have to have Canvas open. It won't be so bad, but I'll pull up the PDFs and again, I'm only if you can, at least as you do your work, number the problem so it's easy. So if like you missed number 10, I could go look at your work for number 10 and then give you some partial credit. But
how many?
Yeah, go ahead.
Sorry.
No worries.
How many points will each question be worth, or does it differ?
That's a good question. I think it differs a little there by how many points there are, but basically it'll be a 100-point question divided by 13. So each question is
Roughly like 7 points.
Yeah.
Okay.
So it's pretty equally that way. Some parts have multiple parts, so but yeah, 7. They're pretty equal across the board.
Okay.
So say 7 to 10 points per question.
All right.
Anything else? Otherwise, we can just.
Can you go over a problem that deals with acceleration?
Sure.
12.3.
Yeah, that's good. There'll be one question on acceleration, and just note that it is. It's really just when they ask for acceleration, they're really just asking you to find the second derivative. So,
Okay.
Yeah. So this one right here, question 4 is a good one. Question 5 is the same thing. They will give you a function. They'll say this is the position function. So let's just take a look at 4 is a little, well, I'll give you the choice, 4 or 5. They're similar, but 5 might be a little harder because it's got a square root. Any preference? 4 or 5? No preference? I'll take the easy route then. No. Actually, why don't I do 5? I think that'll.
Yeah,
Okay.
sorry about that. Yeah, 5 is good.
5 is good. Okay. Just because it's a little more complicated. So let me, with the square root. So Here we go. Let's pull up Word. And put a new window. I'm going to give myself some space here first. Go. Okay, so really, they may not, the question may not say find the second derivative, but in fact, I think it doesn't. It just says find the acceleration. You have to know that the acceleration is a second derivative.
Okay.
So what we do with this is this is really asking two problems. We first have to find the first derivative. And actually, let me do this. Before I do this, I'm going to rewrite this function. Instead of the square root of t, I'm going to write that t to the 1/2, because that's what the square root is. That's what makes that one a little bit more difficult. 6t squared, and in this case, we want to find it at t equals 4. But what they want you to first find the function, and then the last one is you would plug in the 4. So first thing to
plug
do is
in the 4 to the second derivative.
yes, to the second derivative.
Okay.
So the first derivative gives us the velocity. So that's the 1/2 comes down. And then it's t, you subtract 1 from 1/2. So minus 2 over 2. Okay, so then we get t to the minus 1/2. This part, when we take its derivative, 2 times 6 is 12. T to the first power. So that's the first derivative. This is the velocity or speed. Velocity is actually directed speed. So to get the acceleration, we take the second one, and this is what it's asking for. So the negative 1/2 comes down. And I think this is all, so you get negative 1/4. I think I did one of these in the videos. And then you subtract 1 from, so you've got negative 1/2 minus another 2 over 2. So it's going to give you negative 3/2 for your exponent.
And it'd just be plus 12.
Plus 12, exactly. So that part's gone. So that's our derivative. And so that's the A part answer.
Yeah.
And then for the B part, we plug in 4 for t and do the calculation. And what you get is, since the square root of 4 is 2, 2 to the third power is 8. And remember, that's all down there. So you get minus, let's come down. We could rewrite this as minus 1/4 over, yeah, 4 to the 3/2 plus 12. So that's, did I get that right? With, yeah, a minus. So we've got minus. Now the third 3/2, you can plug this to your calculator, but that the square root of 4 is 2. 2 to the third power is 8. 8 times 4 is 32. And so it'll be 11 point something. If you take 1 divided by 32, it's a little bit of a decimal, and we'll get, let's just do that. 1 divided by 32.
Yeah, it's like 11.96875.
There we go. Yeah. And it would be positive. I just did it backwards, 11.96875, and they want it rounded. Well, they don't tell you. Maybe they do tell us up here. They don't tell us how, so I would use 4 decimal places if they don't specify, and then we should be good. Okay? Is that
So it would be
helpful?
11.9688?
Yes.
Okay.
11.9688. And again, those are the types of things. I'll take a quick, if it's like decimals or something, that's why I'll review anything that doesn't get full credit. We're not gonna go back about the 4th decimal places when we're talking feet per second acceleration. But yeah.
All right.
Good, good. So acceleration is just the second derivative of a position function.
Okay. And then one, can you do one on 11.6 implicit differentiation?
You got it.
Just the hardest one you can find.
Sure. Wait, am I in the right place? What did I go to? 11.6. Oh, I'm in 12.6. You want 11.6, right?
Yeah.
Yeah, so, well, let me get to my, there we go. It wasn't, so 11.6. Yeah, here we go. Sure. And again, you might watch those videos. I did go through kind of real painstakingly some explanations of what we do. 2 might be a little more difficult because it's actually got the product rule twice, and it's got e to the x. This one's pretty. This got a product rule too. You
So
see,
when do you know you're going to use the product rule?
whenever you
When
got. So like, let me look at. I'm looking at number 5. X squared times y. There's going to be the product rule here. But this
Okay.
is y squared, so this won't be the product rule because it's just a single item. So, and then like down in 6, I'll use the product rule here on x times y to the 3rd.
Okay.
Yeah. Down here, we'll use the product rule actually twice. This one's probably the worst one. So on both sides, so p times q, we've got to use the product rule, and p squared times q squared, we use the product rule.
Okay.
So any one of these in particular that you'd like to take a look at?
Yeah, number 7 looks fun.
Okay, yeah, that's what I was, and I don't think I've done any quite, and they won't have one this complicated, but or there isn't one this complicated on, but if you can do this one, you'll be just set. Okay, so let me snap a picture here.
I'm sorry, which one?
So we're going to do number 7 in section 11.6.
Okay, thank you.
Sure. Okay, so when we go to take a derivative, I'm going to go ahead and write it out. P squared minus PQ equals 7 P squared Q squared. Okay, so we're going to go term by term. We're taking, in this case, we're taking the derivative with respect to Q. So that's kind of key to see is what are they wanting us to take the derivative with respect to. So in this case, P is acting like how we would usually treat Y. So when we take the derivative of P squared, we just kind of go ahead and take its derivative, 2. So the derivative of P squared, the 2 comes down. Subtract 1 from the exponent, so that's P to the 1st power. And then what we did is we took the derivative of P with respect to Q. Okay, so that part is done. That's the simple part.
Okay.
We get to this is going to be a product rule. And so remember, when we have 2 things that are multiplied, A times B, and we take its derivative, what we do is we take the derivative of the first one times the second one with nothing done to it, plus the derivative of the second one with the first one with nothing done to it. Okay, so in this case, we're going to first take the derivative of p. Derivative of p is 1, right? It's the derivative of p with respect to q. The q tags along for the ride. We didn't do anything to it. Okay, so that's how we do that. And actually, I'm going to put a parentheses around this because noticing this negative is actually going to distribute. The second part, we take the derivative of the second item, which is q. The derivative of q is also 1, but that time we took the derivative of q with respect to q. And I'm just using this. This becomes 1. This is where we could, if you wanted to, you don't have to write this. This is going to go away, but it's my way of remembering I took the derivative of q with respect to q. Okay.
Yeah.
And then we multiply by the first one with nothing done to it. Okay, is that good? All right. Second side, okay, the 7 is just going to be multiplied. You could just pull it out if you want. We're going to do the same thing. We're going to take, and I'll just pull it out like this. We're taking the derivative of p, so that's going to be 2p to the first power.
Yeah.
And again, we took the derivative of p with respect to q. And then the q squared just tags along because we don't do anything. That's the second part. And now the second part of when we've got a product rule, we take the derivative of the second one. So that's going to be 2q. Again, dq, which is, again, that's going to disappear. It's just going to be 1 times the first one with nothing done to it. Yeah. Okay, so go so far so good. So now I'm going to clean it up. This is really here just 2p dp dq. And remember, that's what I'm solving for. I'm going to distribute this negative sign at the same time I'm cleaning it up. This dp, dq is still there, so that's going to be minus, I'm going to bring the q to the front, minus q dp dq. This negative comes here, so that's minus. I'm going to move the p to the front, and I'm going to say dq dq is really just 1, so that's all there is on that. Okay. Over here, I'm going to distribute the 7. Now, if you wanted to, while you were doing it, you could have maybe been writing 14s here, but we'll do that. And again, we'll clean up as we go. So we're going to get on this side 14, 7 times 2. We've got a dp dq. We'll move all the variables to the front. So p q squared dp dq. Bring the 7 over here, so there's going to be a plus 14 here. We'll bring the variables all together, so that's going to be p squared q, and then this was dq dq, that's just 1, so we're not going to write it anymore. Okay, yeah, this was major. Okay, now the goal with this is we get everything that has a dp dq onto the same side of the equation. So since we already have 2 here, let's move this one over, and then the stuff without a dp dq moves the other way. And we're able to do that by adding or subtracting. So what I do is I'm going to add p to both sides, and I'm going to subtract 14p q squared dp dq from both sides.
So it's important to keep the dp over dq for the whole problem.
Yes. And then at the end, what we're going to do is we're going to factor it out so that even though right now we see 3 terms with dp dq, we factor it out so then there will be just 1 dp dq, and we divide by everything else in front, and that'll be our answer. You'll see,
Okay.
once you work these, it does have kind of a flow to it. So, and again, let's just rewrite this. So 2p dp dq, and I'm just rewriting this, minus q dp dq minus 14 pq squared dp dq. That's on this side. The p came over here, so this canceled out. I guess that canceled out there. So on this side we have, you could, either way, I'm going to write as p plus 14p squared q. Again, order doesn't really matter. And the big step here is to recognize that these all have a common factor of dp dq.
Yeah.
So that's what you factor out. Let's change it to green. dp dq comes out, and then the terms in the front are what are left. So 2p minus q minus 14 pq squared p plus 14 p squared q. Now this is one that I would definitely show my work on because it could be a slight error with anywhere along the way. And again, the last step is to divide by this. So I'm instead of doing it all, I'm just going to rewrite over here. This is really our final answer.
Gotcha.
And again, yeah, that was probably the, I feel tired. I don't know about you, but yeah, that one was. Okay, how's that? And this one I've got in a form I can save and I'll post it, but yeah, so sometimes in these we have to use definitely the product rule comes up, and this one it came up twice. It got us to the end.
All right, can you do one, just last one with one that doesn't have the product rule?
Sure. Yeah, and then we'll close off today. Let me come here. So one without the product rule, you're going to see after that it's pretty straightforward. Let's see if that one's left over. So all of these kind of that's the product rule. Here's one without the product rule. It's a lot more straightforward.
Okay.
And again, you guys, you can always come and go as you need. You don't earn any points or lose any points by not being here, but my goal is to be as involved and available to you as possible. Okay, so, and again, the key part is to see what is it that they're asking us to solve for. So they want dy dx, and then they want the equation of the tangent line. Okay, so 4x squared plus 2y squared equals 12. So we're going to take the derivative of everything. Here we get 2 coming down, so 2 times 4 is 8x to the 1 power. And again, this is, since we're taking the derivative with respect to x, you could put dx dx here, or you could choose, hey, I don't need to, right?
Yeah.
We're going to clean it up later anyway. Here, though, when I take the derivative of y, I do it just like I'm taking the derivative. So 2 times 2 is 4. Y to the first power, 2 minus 1 is 1. but I just have to remember to mark this is the derivative of y with respect to x. And then here, when I take the derivative of 12, that's 0.
Yep.
And so it's a lot cleaner. Subtract 8x from both sides. So 4y dy dx equals negative 8x. Divide both sides by 4y. And so dy dx. Now we can reduce 8 divided by 4, so it's going to be negative 2x over y.
Cool.
A little, yeah, you'll see how it's so much more straightforward without.
Yeah.
Now, did you want to see getting the tangent line?
Yeah. Will one of those be on the test?
No. I can tell you.
No.
No, okay.
All right, I'm good, Little Crow. Thank you.
All right, thank you guys. Thank you so much. I'm going to take a little break. Come back on Friday. We'll have a test run through the Zoom system and getting it. We'll do that both Friday and Monday. It's just mostly so that you can feel confident and comfortable about the test and such. And then we'll look forward to just keep preparing for that test for next Wednesday. So we've got a week. Take the time to even just passively view the 4 or 5 hours worth of videos that me working through the programs. And you can turn the speed up twice as fast if you want. I don't know what I sound like at that speed, but anyway, watch it and let me know if there's any questions. Take care, stay safe.
Thank you. Have a good one.
Thank you, you too.
Have a nice day, Professor.
Thank you so much.